Welcome to MathClicks.com! Scientific notation. So, scientists are pretty smart dudettes. They figured out an easy way to turn this hand cramp. There's got to be a better way. There is. It's called scientific notation. So, that was a really long and arduous number. It just went on forever. Well, we could just kind of turn that into this. Yeah, I was going towards 37. You didn't want to spend all day. I get it. Nobody wants to spend all day writing down 37. Wait, what does that even mean? Oh yes, exponents. We just covered that. And 10's the easy one. 10 times 10 times 10 times 10 times 10 over and over 37 times. Well, we know 10 times 10 is really 10 to the 1 power times 10 to the 1 power. Add the powers, that's 10 to the second power. 10 squared is 10 times 10 is 100. Look at that. 2 zeros, 2 zeros. 2 is the exponent, 2 zeros. 37 is the exponent, 37 zeros. You really want to watch me write down 37 zeros? No! Nobody does. That's why we've come up with scientific notation. So we can take these really long numbers and condense them down to the 2 significant digits, or 3 or 4, or however many there are that are significant. We'll get into that at another time. This small number that we indicate multiplied by 10 to that many zeros. For example, if I had 2.5 times 10 to the second power, well, that's just 100, right? So we would really say it's 2.5 times 100. Well, we'd move this decimal 1, 2 times, and it'd be 250. Okay, well, we could have easily just written down 250, but what if it was 250 gabillion? Yeah, writing this down is a whole lot easier than writing down a gabillion. That doesn't exist, but let's just pretend it's a number, because I said so. Okay. Well, it works in the other direction too. This number might represent something sort of like, I don't know, the number of stars that are just in our galaxy, let alone all of the galaxies, okay? So something huge and massive, mega. But what about like the size of one bacteria in miles? That's a very small amount of miles, right? Well, then we would say it's a negative 37. Oh, exponent, what does that do again? Let's see. Any negative exponent really is just kind of like the reciprocal. So yeah, 5 to the negative 1 equals 1 divided by 5, or 0.2. Well, since this is a 10 and not a 5, a 10 to the negative 1 is 1 over 10, or 0.1. Similarly, we add another 0 on the denominator. And that just puts another 0 right there. Yeah. So the tenths place, hundredths place. Hey, hundred, hundredths. It makes, there's a TH in there, so I gotta th it out there. Well, that just keeps on going. Thousandth place. And so on and so on and so on. How we would change that are 2.5 times 10 to the negative 2 power. Well, we'd be dividing it by 100. So we would take our 2.5 and we move the decimal twice in this direction. Our new number would be 0.025. That's why we would use scientific notation. Now, of course, like the other one, the 250, this is easy to write down. But what if you had a gabillion tiny numbers? Well, that's when we take the significant digits, the 2,5 in this example, write them here, multiplied by 10 to its negative exponent, which is just really a fraction of 1 divided by 10 followed by 27 zeros. So scientific notation really saves a lot of writing and prevents rheumatoid arthritis in scientists and mathematicians everywhere. Thanks, and have a great day.